Everything looks very good. I'm well prepared for the high amp discharge test of the Frankenstein battery. Guys, welcome back to another video here from the off-grid garage in sunny Australia. It is 2:30 in the PM and I'm charging with 11 amps. Still, I'm at 15%. That's good. That's good. Well, considering I was on 3.9 this morning and the system was still running. It is all good. Soon we will have more panels here which charge the battery, and hopefully we have some peace of mind then and can recharge the battery a bit higher than 15%. Okay, I think prepared everything. I have got the power supply connected directly to the battery because the BMS has turned off quite a while back. I reached the 3.65 volts, but it wasn't quite all balanced as I wanted it. So I hooked up the power supply directly to the battery, bypassing the BMS. And now we are at 58.2 volts. We've got 2 or 3 millivolt deviation. I think we are fully charged now. Perfect. All right. So this afternoon we want to do a high amp discharge test. Well, it's not a super high discharge test, but at least as high as we can go. We have actually 2 inverters connected. We've got the Xia inverter down here at our Powerwall 2.25. And we can also turn on the Phoenix inverter, which are both supplied from our Frankenstein battery. And we probably get around 110, 120 amps maximum maybe. So this will be our high amp discharge test. Unfortunately, I haven't got any more load to connect to the battery. Well, on the other hand, it's a 14.2 kilowatt hour battery, and this would be something you would install on your house. And then you have an inverter of around 5 kilowatt connected to it to bring you through the evening, through the night until the next morning, and then it gets recharged from solar again. Typical scenario. 5 kilowatt inverter. This is probably what we will pull from the battery today. And the smart shunt test shows us 100%, 57.6 volts. And I've also reset the whole history, so we will get the discharged energy in kilowatt hours and also the ampere hours we have taken out of this battery before the BMS actually turns off. And yes, I have disabled the shipping mode in the Gobelpower BMS. We are not shutting down at 2.65 volts. Today we are going all the way down to 2.5, which honestly will not make a difference at all. Well, this test is more to put some stress on these battery cells. We want to see how the Frankenstein works under stress load. And of course, we want to see if Madi's bus bars are holding up or if we need to go on her channel and give her a hard time for that. But let's decide later when we had a look with the infrared camera on the Frankenstein battery. Okay, let's get started. Turn off the power supply. Turn on this inverter. This will then charge power into our battery shelf here through the multi-plus. So they're synchronizing on this one now. And then we should see the mains coming on and the bulk charging is occurring. Nice. So this is like 40 amps we are pulling from the Frankenstein battery. And we're also going to turn on the inverter. Oh, hear that? That's one of the fans in the Xia inverter. It's not good anymore. Happens only if it's cold. So I have started charging the Tesla already, and I think we have to go a little bit higher here, maybe to 75 or so. So we're pulling 96, 95 amps. Okay, 74% should be fine. Yeah, let's do 11 amps. Let's have a look. Yeah, we are pulling 5.2 kilowatts, around 5 kilowatts, 100 amps. From the battery. This is probably the maximum I would do anyway. We've got a 35mm cable here, which is good for 105, 110 amps maximum. I can potentially go to 12 amps. The problem is in this charge adapter, what I'm using here from 10 amp to 15 amp, it's an Australian thing. There's only a 10 amp RCD in, so it will heat up over time now and it may trip at some stage. Because this test will run for about 2.5 hours or so. Oh, something is beeping. What is that? What is that? That's the Xia inverter. Oh, it's too much power from the Xia. Okay, we have to go back to 11. Something is beeping and I don't know what it is. Okay, go back to 11. Alright, it's happy with 11. That's the maximum the Xi I can do. So 5 kilowatt, 100 amps. Let's do a first flyover with the infrared camera and see how the battery is. And then we compare it again after 2 hours or so. Okay, let's have a look at the BMS first. We've got the 40 degrees here on the cable. This is our negative cable going from the BMS to the battery. And we also have a hotspot here, 45 degrees. This is our positive cable going from here to our bus bar, to the Lynx bus bar. Okay, let's have a look here, what's going on. It's the end of the battery. This all looks good. These are reflections, what you can see there. There's a bit of a... Look at this, this is interesting. These bus bars here, these consist of 4 separate wires into one ring lug on each side. And this bus bar here consists of only 1 wire with the same ring lugs. And look at the temperature difference. I mean, this one is 25, which is not hot. And this one is like 23. So 2 degrees difference. And it looks like a lot, right? So whenever people see these infrared pictures, they say, oh, this is far too hot, far too hot. Now, this is actually 2 degrees difference between this bus bar and this bus bar. And this one looks cold, while the other one looks really hot. But this is just what the picture says. But if you compare the temperatures, it is only 1 or 2 degree difference. I still consider this as okay-ish at 40 degrees at 100 amps. We have a look at the BMS itself. Again, this is like 30 degrees or something on top of it. There in the bottom right hand corner we've got the MOSFETs, about 50 degrees. They carry the 100 amps now. Gets a bit warm underneath, but that's fine. Should be no problem at all. I'm a bit concerned about my aluminium bus bars here, but they holding up pretty well. Yeah, here you can see these 2 bus bars again. This is 1 solid cable, and these are 4 separate single cables, but they are crimped into 1 ring lug, same as this one here. But this one doesn't heat up as much as this one. That is interesting. Well, it's not even warm. It feels cold. Yeah, this is probably a bad crimp here. This is one of the first crimps I made. This is the long 35mm cable we used to connect the battery 1.0 to the Phoenix inverter. This was one of the first setups and one of the first crimps. So it's not even 50 degrees. Look, it's not that much. Same over here. It's a bit warm. All good, all good. I'll keep checking it. Okay, the shunt actually tells us we've got only 49 minutes until we are empty. Oh wow. That is very pessimistic. I mean, it's a 280 amp hour battery, and if you pull 100 amps, that should give us at least 2 hours, 2.5 hours, but 49 minutes. Well, look, it's already down to 81%. Well, here on the BMS, we are still on 93. That looks better. What we can probably do is we can actually set the inverter, our Phoenix inverter, except to 12 amps. This gives us more power. Yeah, 5.5. Look at this, 107 amps. Nice. Okay, so we are now fully recycling this energy from the Frankenstein battery here into our battery shelf. We've got about 20% loss or so. By doing this and charging the vehicle from the battery, going into AC, AC goes into DC again inside the vehicle, probably another 20% loss. But hey, if you can recycle 80% of the energy in this Frankenstein battery, that is pretty good. I'm happy with that. 16 degrees. 17, 18, 19, 20, 21. It's interesting that the batteries are getting hotter at the end and beginning. That opens the door to many speculations now. Why that is. I had the smart shunt still on 100 amps sitting from our last test with the Jackie battery. That's why the state of charge was totally out. So we are now on 70% here on the smart shunt. And we are on 70% in the BMS. Is that easy? So we've just enjoyed a beer outside in the last bit of sun here on the driveway, and something started beeping here. I don't know, but the inverter flashes there. I think we've got an overload alarm. And we're discharging with 50 amps only into the vehicle at the moment. The XIA inverter is still running. The Phoenix has a high temperature alarm. How can it have a high temperature alarm if it's just 16 degrees inside here? How can this happen? Look at this. High temperature alarm. This is just I don't like this Phoenix inverter at all. Okay, it will turn on again at some stage. We just need to lower the amps to 11 maybe 11 works. Okay, let's just wait. It will turn on again, and Phoenix inverter. It's not good. Alright, after a few minutes the Phoenix inverter started working again, cooled down. What do we have here in the garage? 17 degrees, you know, it's not like it's like 40 or something, you know. And we again, after 10 minutes, we have a high temperature warning. So I need to go down again with the Phoenix output power. Let's go to 9 until this warning disappears. I mean, it sucks in 17 degree cold air. How can it overheat, you know, in these conditions? It's a 3 kilowatt, no, it's a 3 kVA inverter. And this is just ridiculous. All right, let's have a look at the shunt. We are at 38%, it claims, or close to 5 kilowatt we are pulling, 95 amps, and it's still 1 hour and 2 minutes to go. The BMS is on 37%, so very close together. Yep, all these numbers are lining up. Oh yeah, I can feel actually that these cells are warm. Yeah, these ones are cold. These ones are cold. And the first one is hot on both sides. And I'll tell you later why that is. It is not because the BMS radiates any heat in this direction. No, there's another reason for that. Why this cell and this cell are the hottest. Alright, after 1 hour and 41 minutes of discharging, we have the following temperature situation here. So the BMS has heated up to 65 degrees. See, it's like a sandwich. See, that's really hot inside. What do we have here? 47 degrees. You can see the cables are heating up like, what temperatures are we talking about here? 26, 27 degrees. You can see actually the single cores of these cables. 26 degrees. This one here is 38. Yeah, that's a bit warm. Could be a contact issue between the ring lock and the terminal of the battery. Apart from that, nothing to see here. 1 hour and 45 minutes now of discharging. So let's measure some temperatures. Starting over here, this cell had actually 16 degrees only when we started with the test. It's now 22. So let's go further towards the BMS. 25. And this is now here 24. This is the one close to the BMS. And here on this side it has 28, 27, and it gets colder on this side. Interesting. So still discharging with around 100 amps, 5 kilowatt, and we are 2 hours and 4 minutes into the test. 10.8 kilowatt hours, 211 ampere hours discharged so far. It will be another half an hour. Oh, yeah, doing the BMS sniff test. Something is smelly here, but I think it's my aluminium bus bars. They are really hot. I mean, like hot. So guys, we are down to 46 volts. Lowest cell is 2.7, and my screen recorder Streamlabs makes an update now. I hope I still make it. Okay, the BMS, no, the smart shunt says we are at 0%. Oh, something is beeping already. What's going on? 13.9 kilowatt hours, 275 ampere hours. And we are still discharging with 106, 107, 110, 11 amps. 4.6, we are very close. I don't think I make it. So this is your screen recording for today. Sorry for that. I should have been better prepared. Now everything is beeping. Smart BMS, low voltage. Do we have a low? Yes, we've got a cell under voltage alarm and a pack under voltage alarm, but no protection. So the BMS is still running. Oh, the screen recorder is back. Start this on the mobile phone here as well. 14 kilowatt hours we've made, 276 ampere hours. Still discharging with 100 amps. It is amazing. How good is our Frankenstein battery? Now it beeps, something beeping. There's beeping everywhere over there. I don't know what it is. We keep going until everything shuts down. 2.57, cell number 1 is our lowest. And we are at 14 kilowatt hours. Still 113 amps. It is still going. 14.1 kilowatt hours. Yes. 278 ampere hours. That is an amazing battery. Incredible. 2.5. That's it. Now the BMS has shut down. Cell under voltage protection. Ah. Shut up. It's the Zerbo. Okay, that's it. Almost 280 ampere hours pulled from the Frankenstein battery with 100 amp load. That's a 0.35 C or something, which is here on the screen. That is an incredible result. Guys, I'm very, very happy with this battery. Let's do the quick... Okay, starting here at the BMS, 52 degrees. Oh yeah, my aluminium bus bars, they are quite hot actually. Alright, here's the cable with 50 degrees. And then we go into the batteries. We can see here the first row of cells, the first 2 rows actually, are a bit warmer than the other ones. Isn't that funny? And over here it's all nice and cool. So what temperatures are we talking about here? This is the right hand side of the battery pack now. 30 degrees in between the batteries. You can see it measures actually the gap in between the batteries. This is our hot spot. So the batteries have warmed up to 30 degrees. Yes, they are nice and warm. They're not cold anymore as they were before. And even here, these batteries have 36 degrees. And here our first 2 ones. Okay, that's a reflection of the terminal. Yeah, we're around 37 degrees. Battery temperature here. But look at this battery. How good is it? Of course, we've got a huge deviation of 500 millivolt between cell number 6 and cell number 11. 11 is the EVE 304 ampere hours, one of the oldies, bought in 2021. It is only cell number 1 and 2 which are the lowest capacity cells, and hence we are shutting down before we reach the 280 ampere hours. But apart from that, I mean, I'm super happy with the result. This was 100 ampere hours for like 2 hours and 44 minutes. There was a discharge test for 2 hours and 44 minutes with 100 amps from this Frankenstein battery. And we have reached 14.1 kilowatt hours and 278 ampere hours. So we are very close to reach the rated capacity of 280. And to be honest, this is a very unusual scenario to discharge your battery with over 100 amps for that long. What an amazing battery we have built, right? I mean, we almost pulled 280 ampere hours from this beast. And also the BMS had no trouble to disconnect the 110 amps. Well, unlike the JK BMS, if you remember. Yeah, there was a bit of magic smoke involved. But here, 110 amps at 48 volt, no problem. Okay, I think this also concludes our test series for the Gobelpower BMS. I think we have tested everything now with it. We have a very good understanding how it works. And in the next video, I will give you my final verdict about this BMS. So this video will come tomorrow, so stay tuned for that. Alright guys, as always, thank you so much for watching. Thanks for all your great support here, for all these beautiful people who have donated money to the channel, buying me a beer. I very much appreciate your support. And until the next video tomorrow, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. 278 ampere hours. Crazy.